think everyone's here. Welcome, everyone. My name is Gabor. I'm a developer relations engineer from Oculus, and today we're going to talk a little bit about rapid development with VRTK, VRTK 4 specifically. So why exactly are we talking about prototyping with VRTK here? Well, Unity and Oculus are about to launch a course on Unity's Learn platform called Design, Develop, and Deploy for VR, in which we'll walk through everything you need to build a full vertical slice of an escape room game. There's supposed to be some awesome audio here. No worries, I got you. So beta signups are actually live. You can go to the URL here, sign up, access like the first 3 parts of the course. I think there are maybe 11 total. I forgot the number, sorry. And the engineering parts of the course actually use VRTK to build this prototype. So today we're gonna kind of get into Unity and just build something the way the course does it, and it kind of ties into that. So that's all the slides I had. Let's actually jump into Unity here. So I have a pretty basic scene set up here, and I'm just gonna kind of go over some of the things that are already here. Some of this will be covered in the course if anyone's interested in signing up. The first thing we have is this OVR camera rig. If you've ever worked with Oculus-specific VR stuff, this should be fairly familiar. This just lets you get like the position of your controllers and headset in world space here. And the only kind of non-standard thing that's on this OVR camera rig is this linked alias association collection, which is a way to link a camera rig to what VRTK thinks a camera rig is, in this case, this tracked alias. And it's pretty simple to set up, but the nice thing here is you can have multiple camera rigs in your scene. So you can have your OVR camera rig, you can have your Unity XR camera rig, and whichever one is active is the one where your headset and hand transformations will clone into this tracked alias. So instead of having to attach things to your camera rigs for every camera rig you have, you just attach stuff into this tracked alias, and this tracked alias will mirror the currently active camera rig there. And I've actually already added some stuff in here. So we got this left and right controllers, and here I have these interactors. And these are just some standard prefabs that come with VRTK that let you interact with the world. And they're covered much more in depth in the course if you're interested in how those work. For now, we're just going to kind of skim over a few of these details to get to the interesting bits. So just to show how this works, let's add a something that we can interact with. If I could type, that would be awesome. So here we have some interactables. These also come with VRTK. And the way this works is you have a primary and a secondary action. So the primary action is whatever you grab with whatever happens with your first hand. Secondary is whatever happens with your second hand. So primary grab, secondary none is I pick something up, and if I grab it while I'm holding it, nothing happens. Primary grab, secondary swap is if you pick something up and you touch it with your other hand, and it just kind of swaps around. Pretty self-explanatory once you kind of start using these. So I'm gonna put this somewhere up here. Let's make it a little bit nicer to work with. Scale it down a bit. Yeah, that should do it. And just jump into VR super quick. So very minimal setup actually, like to get from 0 to this part probably takes about 10 minutes. And that's kind of why we chose VRTK for the course. It's very quick and easy to get up and running, and a lot of complex interaction stuff is taken care of for you. I hope I don't punch anything. So I can pick this up, because this is a secondary none, nothing happens here. The nice thing is if I like throw it, the velocity of my hand is applied to the object automatically, which doesn't sound difficult, but it's actually just one of those things that you don't think about that makes like VR development a little bit more challenging. So let's bring something a little more interesting into this scene. And so VRTK comes with a sample scene called the farm scene. And inside of this farm scene, there's just a bunch of things that you can interact with. And I'm going to bring one of those prefabs in here. So that would be like this handgun variant. Now, the nice thing about the farm scene there is it has everything. It has locomotion samples, it has like different kinds of interaction samples, and if there's anything in VRTK that you want to use that's in the framework but maybe not documented, you can just open up the farm scene and figure out how it's all hooked up. So if we were to jump into VR right now, we could grab this handgun just like we grabbed this cube. We could throw it, but we couldn't actually shoot it, right? Because when you think about it, if you pull the trigger on your controller, you only want certain game objects to get that message. You don't want all game objects to be like, hey, the trigger was pulled, let me shoot stuff. So you only want that to happen when this object is actually being touched. So for that, it has this float action receiver. And we need to hook this up real quick so that it actually receives events. So to do that, we're going to have to add a few things to the tracked alias here. And we're just going to have to add float action sources here. So I'm going to drag this here, this here. And I like to name my stuff with left and right .l.r whenever I'm doing stuff in VRTK, just because it's such a visual framework and you do a lot of work just inside of the editor here, right? So the way to configure these is there's this source container, which is where the action that we're sending is going to originate from. It's not actually going to originate from this prefab, it's going to originate from somewhere else. And a source action, which is what action triggers this particular floating point action. So that's going to be float action. So I'm going to go into these interactors, look on the interaction logic grabbing, and there's this attachment origin. This is where game objects attach when you grab them. So we really just want these to be the actual origin here. And then do the same thing for the right hand. I'm going to be doing left and right quite a bit here. So while we're looking at this, I also kind of want to point out that this is just kind of how VRTK is set up. Under the hood, VRTK uses Xenia as like this framework for sending and receiving events. And under each of these game objects, there's a bunch of objects that have like Xenia components on them. And then the actual interactors are just these facades that configure and work with those Xenia components for us. So I hooked up the attachment origin, what I want the events to be sent from. Now we need to hook up some events. I set a few of those up here under input events. We got grip triggers and index triggers. Those are the only things that we're going to use here. And both of these have this OVR input axis 1D script on them. It's a pretty easy script. Like I said, Xenia is the name of the event framework here. So this float action lives in the Xenia.action namespace. All of these actions have a receive method, which just takes the appropriate data type. And here we just call some Oculus specific code to get the value of the trigger that's being pulled. So this is just like just some glue code that lets OVR stuff work with VRTK. And then on each of these I also have, because these are floating point actions, I have this float to Boolean converter, again, that just comes with VRTK, and then a Boolean action. So any of these game objects can be used as either float or Boolean actions here. So for the left hand, let's hook this up as the index trigger left. For the right hand, let's hook this up as the index trigger right. So now we have it hooked up where these actions are, So now we have it hooked up where these actions will trigger, but we need to make sure that they trigger to external sources as well. So for that, I'm going to look for a send to external emitters. And there's one in the left hand and right hand, and this is why I have to do .l.r down here, just so I can easily tell what hand what belongs to. So let's do, this is going to be right. This is going to be left. And all we want to do here is whenever an event is sent to these external emitters, wrong game object, just want to make sure that these actions actually start. Set active collision. And then we just repeat the same thing for the right controller here, right? So send to external emitters right. And like I said, this is just nested kind of deep in this interactor class here, but these are just the Xenia components that the interactor facade on the top actually gets. Let's see, float action right, interaction logic, publish start. Active collision set active. So whenever we look at these kind of events down here, they eventually all bubble up into this interactor facade, and you can hook up events over here too, but the arguments to these events are slightly different, which is why I actually have to dig down and into these. So now we have these events, they're all hooked up to begin publishing whenever you touch something. So whenever I touch the game object, it's going to start publishing these float events, which are hooked up to the trigger, and the system's gonna lie a little bit and say that the float events actually come from our hands. So the only thing left to do is to make sure that the actual gun is listening to these events. So if we look at this handgun variant here, underneath it is the float action receiver, and we'll set our action sources here to 2. And we'll set the origin to the right here. Float action, we'll set the origin to the left here. Not the touching, the grabbing, attachment origin left, and then this action. And these actions are forwarded, right? So this floating action comes from this index trigger action here, because that's how we just configured it like a second ago. But then this has its own float action down here. So whatever that index trigger is gets routed up to this float action, and if we hook up these float actions instead of the index triggers directly, we can very easily just switch what triggers an action without having to come here and redo all this work of configuring these kind of prefabs. So I think that should be everything. Let's hop into VR and hope it actually works. There's like a 0% chance that when I was rehearsing this, it didn't. So we got the gun and confetti shoot. Woo! So it's a lot to cover, kind of quick, and the handgun was actually already built for us, set up by VRTK, so maybe we can do something a little more interesting, a little bit more from scratch here. So what I want to do is I want to turn this object that we made in the beginning here, this primary grab, secondary none, and I want to turn this into some kind of an interesting crossbow. Just going to rename this to crossbow. And I'm just going to disable this default mesh and add a better mesh that looks a little bit closer to a crossbow. I do have to warn you, I made all of this art myself, so it sets a new standard, really. All right, there's our crossbow. There's a couple box gliders on here for where you can grab the crossbow, and I already went ahead and made a crossbow script we can attach to this. I'll go over the script super quick, but it's not really that interesting. If it opens. Thank you, perfect. So the crossbow has 2 states, empty or loaded. There's a game object for where the arrows can attach to and shoot from. There's this arrow pool, which just reuses arrows so we don't instantiate a bunch of game objects, and a force that we're shooting the arrows with. Some logic to keep track of the internal state. The awake method here just sets the internal state to default values. We have a shoot method here, which actually requests an arrow from the arrow pool, adds some force to it, and shoots it off in the distance. And a reload method, which will go through and reset our state to be loaded so we can actually shoot an arrow. So let's get this configured here. The first thing we're going to need is some place to attach the arrow to. That's this arrow attachment point. I'm just going to drag my existing arrow prefab in here. This does not need anything because it should just be a mesh. And we'll hook this guy up. And then I guess we need an arrow pool as well. And the arrow pool just takes a prefab that it's going to pull. This script isn't too interesting. I don't think we really need to go over it much. It's pretty much exactly what you'd expect it to do. All right, so we have this crossbow. We have some logic attached to it. If we were to jump into VR right now and try to do anything, it really wouldn't. We'd be able to pick it up, drop it, whatever. We wouldn't be able to shoot it because it's not actually getting the same kind of floating point action that the gun here was getting. So that's kind of the next step in making something fun and interactive here. So we're just actually going to copy what the gun does here. So let's look for float action receiver. Float action receiver, we'll drag this guy in here. And we're going to mimic the way the gun is set up. And whenever you're working with VRTK, if there's something in the farm scene sample that's already set up, it's a good idea to try to figure out how it works and mimic it. So I'm going to disable this the same way the receiver is disabled here. And to configure the receiver, we just need 2 elements here, which is going to be our attachment origin and floating point action, or float action, sorry. That's the right, and then for the left, we also need attachment origin and float action. Perfect. So if we were to jump into VR now, we'd expect this to kind of work. It still wouldn't though, because this game object is disabled here, so like none of these actions are actually going to go through it. So what we need to do is we need to make sure that this game object is enabled on grab and disabled when it's no longer being grabbed. We could hook it up under this facade here where we have grabbed and ungrabbed, but these take the interactor facades, and I thought it might be a little more interesting to see where does grabbed and ungrabbed action actually originate from. So the game object is called automated output primary grab action, quite a mouthful. And we have two of them. We have one that is inside the handgun here, and then we have one that's in the crossbow, obviously the one that's in the crossbow. So whenever this crossbow is grabbed, we'll have two actions that are going to happen. We're going to enable this float action receiver game object. I'll set that to active. And then underneath this, we have sources, which is where these actions originate from. And I just want to make sure that those are enabled. And then we'll do the same thing for ungrab here, right? So ungrab here, we'll add 2. And we'll do this in the reverse order. So we'll disable the game object here. And then we'll make sure to clear these sources before we disable the game object. All right. So if we go into VR now, it would almost work, except I forgot to call the shoot method. So on this float action receiver, whenever the value of this floating point here changes, I'm just going to add a new callback here, and we're going to go crossbow logic shoot. So now we should have a single shot crossbow if I did everything right here. I don't know if you guys can see that, but there goes an arrow. And no way to shoot another arrow, so this is useless now. All right, couple giggles. For anyone watching this on YouTube, that joke killed. The audience loves it. All right, that one did. So next up, let's make this thing reloadable. And for that, we're just going to add a crank to reload. So you're going to pull, shoot, and to do the reload, we're going to use a rotational transform drive that VRTK provides. Rotational transform drive. Let's see, ooh, that's a big old box. So let's disable this default mesh, make it a little bit more like a crank that would belong on the crossbow. And then I guess let's also place this in a sane place where I can interact with it. Yeah, I should just about do it. Perfect. So unlike the crossbow and the gun, this doesn't have any physics on it. That's pretty good. We kind of expect that. And this does almost exactly what this does exactly what you would expect from a rotational drive. It allows you to rotate the object. It allows the object to rotate back. You can use this for a door, anything really. And the way I want to configure it for here is we're going to rotate around the y-axis, which normally there's a gizmo, but did I? Oh, you know what? Sorry, I dragged the visual mesh, not the actual prefab. My bad. There we go. All right, cool. Now we're here. So there's this visual kind of widget here that kind of shows us which axis it's rotating on. So let's rotate around the y-axis. Let's move towards the target value, which we'll set to 1, which is like at 0. And our range is going to be -7520. And let's move the drive speed up to 200. I think this should just about do it. And then all of these prefabs are built with other prefabs that are kind of functional, that are just the default functionality in VRTK. So you'll notice under this rotational drive, we have a primary grab, secondary swap, which should kind of give you an idea for how this drive actually works. And what I want to do is, whenever you touch this rotational drive, I want to disable this move to target because I want it to follow your hand. So here we'll just use the methods that are a part of the interactable facade here. So we have grabbed and ungrabbed, and on both of them we'll bring in the rotational transform drive. And whenever we grab it, we want the move to target to be false. And when we ungrab it, we want the move to target to be true. And then one last thing to do here, whenever the normalized value of this rotational drive, actually before we do that, let's jump into VR and make sure it's configured correctly. So unlike the other two objects, there should be no physics on this, so it's just kind of here, and we can grab it, and we can pull it back and release it, and it works just like a crank. Right on. All right, so let's attach this to the crossbow. Made an attachment point here for this. Perfect. And we'll just zero this out. And then whenever the normalized value of this changes, we want to add a new callback here, and we'll just do the shoot method of the crossbow logic, or reload method, I'm sorry. And it's not too much fun just to shoot these arrows into nothing, so I have some targets to shoot at. It's a carnival shooter type thing. And all of these targets are responsible for returning the arrow that hit them to the arrow pool, so we'll just hook that up real quick. And with any luck, that should be it. Yep, we got some targets moving. Can reload the crossbow. And if I was a better shot, this would be a funner game. There we go. All right, got to. I'm going to quit while I'm ahead on this before you guys see how bad I am at shooting stuff. All right, so that's it. Like, that's pretty much all it takes. In about 20 minutes, we went from nothing to having a crossbow mechanic here, where you can reload, shoot, and just repeat playing. That's really all I have, so I'll open the floor to questions if anyone has any. There's 2 microphones.
Are you funding VRTK from Oculus?
We have given VRTK a developer grant, so we are kind of funding it. It might not be the type of funding that you would expect, though. Yeah, but we did fund some development.
Hey, that sounds and looked like a whole lot of work for instantiated objects at runtime, hooking up all these hooks inside prefabs and over prefabs. Is there a way to make this easier? Because I know VRTK 3.3, my biggest hassle was like losing references to other prefabs in my scene, and especially with like networked things where the camera is instantiated at runtime is really hassle. So is there a way to make this easier?
There would be, not really out of the box though. So if you want anything that's kind of like synchronizing with stuff in the scene or whatever, you could write some glue code that just sets these references for you automatically. But what I would actually do is I would look at how these facades are written, and I would edit them to be more aware of the scene and network stuff. Generally, I try not to instantiate too many things at runtime, so this hasn't actually been a problem for me. But if you do want to add like networking support to this, I think a really good place to start is just to like make the facades be aware, because these facades, so the idea is you actually shouldn't have to do all this dragging and dropping that I did here. I kind of did that because I thought it would be interesting to see how these things are actually built up, right? Like most of the time when you interact with VRTK, you're only going to be interacting with these facades. You're going to be like just adding grab and ungrab stuff here directly. And then these facades are the things that configure all of these nested prefabs. So if you have a custom facade that does that's aware of networking, that's aware of like where objects need to be duplicated or whatever, it would be pretty painless to do. It's just a little bit of elbow grease to write that code.
And follow up, if I see this correctly, what's the interactive facade? So is this like, do we have all our hookups have to get this function over to this, or is this like an internal thing?
So interactable facade here. There's
interactor facade. The things the events want to give them.
Right. So the interactor facade is just a standard part of VRTK here. You don't have to attach them to hands. You can attach them to whatever. And like by default, they come with this little cube. They're pretty easy to change to like hands or whatever. I think that was your question, right?
Yeah, yeah.
Okay, cool. Yeah, so that's just a part of VRTK. How the interactor facade works, how you can change this mesh to be like Oculus provided hands and actually like do gestures and stuff. All of that is covered in the Design, Develop, and Deploy for VR course. So definitely check that out if you're interested in a little more, how do I get this set up? How do I not deal with all of these nested prefabs?
Is the course that you mentioned in the beginning also usable for the Oculus Quest?
So the course is designed for the Rift S and Rift, but I have compiled it for the Quest, and it does work out of the box. So does this.
Okay.
And like no changes needed. Like literally, you just change your compile target, and it's good to go. You know, between Oculus Utilities and VRTK, all of that's taken care of for you.
Hi there. Thank you. Is there any plan on improving the documentation on the website? Because currently it's kind of really not being helpful.
Right. So that's kind of the challenge with VRTK right now, right? The documentation isn't great. And if you want to figure stuff out, you have to go into, as soon as it loads, into this farm scene that they provide and kind of figure out how the farm scene is set up. There is a Kickstarter that that is being run, or will be run maybe, by the VRTK folks for better documentation. And Oculus will also be providing some documentation closer to when the course fully rolls out. So we're actively working on making that situation better.
Thank you. One more question. What is the development time frame for this new version? Because I remember on the website say it's still under development, don't use it on live project and all that. So
I actually find this pretty stable. I don't have any insight into when this will officially release. I find that the current version is very stable. It's worked really well for me. The major thing that's missing, like you mentioned, is documentation. So I actually would use this personally.
okay, thank you.
Of course. Any other burning VR questions? All right, I think that's it then. Right on. You guys get a little bit of time back.